Science of Climate is a recently deployed master degree offered by the University of Bologna.
Climate is a wide discipline with connections to biology, to hydrology, engineering,
geology, physics that interlink and give extreme events, extreme responses, long-term trends.
Our students have different backgrounds. Most of them come from STEM bachelor degrees in physics, mathematics, chemistry, engineering, and also environmental science and geological sciences.
And so the challenge of this course is to bring together two departments of the University of Bologna that together can overview from an academic point of view the different elements of this puzzle that climate brings us to try to solve with a new approach.
Students in our degree have to solve problems associated with climate change, the impacts of climate change on agriculture, the impacts of climate change on water management and infrastructure and so on. The degree provides a wide spectrum of expertise.
It is an international master degree fully taught in English, so we accept students from all the world.
There are a number of research institutes around the city that allow the student to do their internship and often thesis, like CMCC, ENGV, and also CNR in a tight collaboration with the university. There are also cases in which students end up also traveling overseas to Canada, British Columbia, Europe, of course. And this often happens also because many of the professors of this master had a long experience abroad, and this helped to build strong connections with research institutes and other universities around the world.
I'm teaching spatial ecology in R, which is related to developing algorithms for measuring the variability of ecosystems in space and time. Climate is dramatically impacting the biodiversity of space in the planet, and we are measuring the major drivers of this change. We are doing that by developing our own free and open source algorithms, which help students to directly deal with the analysis of big data in climate change.
I teach two courses in this master degree, one about the variability of the climate, it's called climate variability, another one on the physics of climate change. So we want to give the students the basics, the physical background to understand why climate change is happening and how the climate system works.
I've been teaching a few courses, and one of my specialties is climate variability and tropical RC interaction. The way I've been teaching these topics is having an important component that practical hands-on problem with students. For instance, we use observational data and modeling data to do simple analysis, but also more refined, also more advanced analysis.
I teach physical oceanography, and I enjoy to transform physical oceanography to be closer to the need of climate science. So my course has been evolving in the years, and now it is preparing the students for more interdisciplinary work that is required for the science of climate and for the science-based management of climate change.
We aim to train two different professional figures. The climatologist is focused on the understanding of the climate system and the modeling capabilities. It will be able to provide new parameterization in climate modeling. This is more focused on the impact of the climate change on the Earth system, especially on the different components of the climate system. It's focused on understanding the possible mitigation measures and adaptation approaches that could be useful or important in order to be more resilient.
I chose this master degree in science of climate because I had a mathematical and scientific background. My aim was studying and trying to understand the physical and biological mechanisms in order to do something for future knowledge and because I really care of what we're talking about.
I think that this master provides a very complete overview of the climate system. So first of all, we have a very strong background on the atmospheric and the oceanic circulation, but we also have an important look at the paleoclimatology and the hydrogeological risk, which is also very important due today.
I think that this master is a very good choice if you want to study the physics that is behind the climate changes and behind the climate itself, not only climate changing, but in general the climate. And I very suggest to take this course since I think that professors and colleagues and also the topics that you are going to analyze are very important nowadays and they are very, very interesting.